Okay, let's get started, guys. Homework. Any questions on the homework at all? Yeah, Reagan, go ahead. 32B, okay, let's talk about it. All right, so for 32B, they say Schroeder is given the following points and asked to find the area, but our graph here is not big enough. Find the area of Schroeder's rectangle. Explain how she can find the new area without graphing the points. So if you just think about it, if these share the same x coordinates, then you see the difference in the y course is 25. And that's going to be straight up vertical because they share the same x coordinates, so the y coordinates are different. So that's going to be going up from 150 to 175. And these are also the same, and you see the same thing. We definitely have two sides that are 25 each. Then if you notice, you have 2 points with the same y coordinates, 150, 150. Those are horizontal sides, but the 3 to 4 to 6, and likewise for the 7 and 4 points. The difference between 4 to 6 and 3 to 2 is 104. So if I have 104 for one length, 25 for another length, there would be those two multiplied together, which of course is a calculated time. We 2600. So yeah, just take the difference in x and y coordinates. But fortunately, these coordinates were all shared similar x or y values, so it made it easy to kind of visualize. So yeah, Kira, good.
2-33.
Yeah, and it's not shown. That's his fault. Yeah. Okay. I know he's just slacking. I don't remember what that problem is. So let me pull it up here. Let me pull it up.
I said in my class when I was raised, I just said, talk with each other at your table and see what you guys got. All got the same answer. And if you didn't.
But see, I have a good excuse. I had a car situation on Thursday, at a CLG on Friday. So I was busy. I was very busy.
Bad. Just
But-
check with each other. See if you guys got the same answer.
No, I'll pull it up. Yeah. Yes. Do chat with each other. I'm gonna pull it up right now. Here we go. Yeah, you don't know. No markings. We're okay with that? You can't tell? Yeah, good.
Oh, okay, so I checked this in my homework here, but I didn't like see it, like I was checking, but I don't know why it didn't pop up, so I didn't do it.
Oh, did I assign it?
It's the part 8, but like it just never popped up in my other information folder. So I'll just do it today.
Oh, because I made it to at 8 a.m. That's why.
No, because I looked at it like
That's it.
like Friday.
Weird. Yeah, because I just submit assignments. Yeah. Okay. Is this homework 8 or 9? I mean, it's worth. Hold on. This is homework 8. Got it. That's correct. This is homework 8. Correct. Yeah. Whenever you can. Yeah, that's fine. That's fine. Okay, guys. Let's get back to this. Yes, Maggie, go ahead.
243.
Mm-hmm.
I want 2 -1. Yeah, me too. 6 -1 instead of 3 7.
Hold on.
Yeah.
I didn't do that.
Wait. I'm confused with the question.
Lifted it over that and you're
Oh, okay. Hold on. Wait, so say again. You got what again? Oh, no. Here's the reason why. I got it. Okay, let me expand that. No, these answers are correct. So what you want to do. Everyone got so quiet. It's nice. All right. All right. So let's extend this. Okay, so we'll call this like point A and point B. So point A has to jump over this line. Now think about point A right now is 2 above this green line, right? So you gotta go 2 below. Because you're reflecting about y equals 1, not the x-axis. You're reflecting about y equals 1. So you have to see the distance that they're away from each other and use that same distance. That's why I said 3, -1. No, according to the diagram, that's 3, -1. Right here. That's 1, 2, 3. So right now it's at 3 3s. And if you're jumping over y equals 1, it's at 3 -1. And likewise here, That's 4, 5, 6, 7. So if that's 7, 3, that's a 7, -1.
Cause should I just draw it wrong?
I think so. Yeah, you drew it wrong. Yeah.
Okay.
Yeah, you drew it wrong. That's what happened. 3, -1 is 7, -1. Because right now you have points at 3, 3, and 7, 3. So you jump in there. I'll take one. No, you didn't reflect. Actually, that's your one. That's weird. Oh, you translated. You didn't reflect. You translated. That's what you did. You slid. You didn't reflect. You got flip. You didn't flip. That's okay. This is why you guys are doing homework, right? It's okay to make mistakes. But it's just hard for me to tell until I see it. So thank you for showing it. I appreciate it. Anything else you guys want to talk about on the homework? Yeah, Regan, go ahead. Okay, cool. Good questions. Anything else? No? Okay. Let's just take a quick. That's another couple of things. All right, let's move on to new stuff. So what we need to do is we have to finish up the 214, 215 notes. So we did these notes last time where we got scissors to cut them. We did some stuff. I think we got most of this done.
Yeah.
Can I see someone's notes just so I'm making sure I. Maybe that's page 1 and 2.
When you make it.
Oh, I'll probably look at that. That's quite cool.
Oh, that's.
Yeah, that's quite cool. Yeah, I ran outside. I saw.
Is it out that window?
Yeah, I got photos of this.
Can I saw the photo. I saw the photo. I saw the photo. Yeah, we saw the photo. For volleyball. Can I see it?
Sure. Hold on. Okay, so 239. Okay, guys, start 239, and I'll try to upload. Here, let me upload the video if I can. Yeah, but it's all good. I mean, I got it all out. So, one sec here. Yeah, here's a video. Really, sorry, I don't have the video. That'll take a while to upload. See your car. No, the video of like the fire department getting a chainsaw and getting the tree out. See here. Yeah. Actually, I saw you guys 2 periods before it happened on Thursday, right? Yeah, so you can see it's just completely smushed. I did grad school there, yes. Oh, good eye. Like saw that all trees. Yeah, and like that's the mascot for Stanford. It's in the tree, right? It's like a pine tree, right? Is that a redwood tree? Yeah, exactly, right? Yeah, and then that's after the fire department got some of the tree out.
Did yours get the worst?
Yes, it got the worst. But you know what's even crazier? I was here at 6 in the morning on Thursday because I had a call that I had to take, so I decided to take it here. So waiting to take at my house and hitting traffic after 7 o'clock. So I was like the first person on campus. There's all these spots, and I chose that one spot. That one spot where yes, that one spot.
That's
And then that's you can see how the roof is I just don't think you could prepare that. I started like I didn't drive because it's too dangerous to drive. No, but the car started. I did start the car, but I wouldn't drive because I'm not gonna go in the freeway like that. And there's glass everywhere. Yeah, but I was able to open the trunk, get the stuff. I got the car totally cleaned out and empty, and I got a rental car. So at least I was able to get all my. Actually, I forgot my cheap sunglasses inside, so I lost my sunglasses. That's okay. It's like $10 from Target. Thank you. You can do a GoFundMe. Yeah. Well, thank you. You can see there was so much weight on that limb, it just snapped. So that's what happened. It just snapped, and yeah. I don't, sometimes these trees just can't they have structural issues.
Can I point to where I was?
Yeah, sure. Sheesh. I'm glad no one got hurt, because that's really scary. Because that would have I mean that could have killed somebody. Yeah. So
Anyhow, all right, you guys, let's get moving here. So let's pick up at 239. All right. So I'm gonna, guys, quiet. I'm gonna kind of just do more lecturing today because we need to kind of move fast with these notes because we're a little behind. So for 239, what can the triangle angle sum theorem help you learn about special triangles? So if it's equilateral, it means all sides are equal. We know this. All sides are equal. So what does that mean about the angles? Then all angles are equal, right? And because the triangle angle sum theorem states that all angles add to what number, guys? No, triangle.
Okay.
180. So it has to be 60 degrees. So you have to split equally among three angles, right? Now consider an isosceles right triangle. That's 90. So that calls like x and x. So x plus 90 has to equal what? What do all of them add up to again? 180. And you solve for x. And I'll stop to give you guys a moment to just reflect on this. So
Yeah, so, and again, I don't wanna go too fast. I actually have discovered, a couple since my other period, that some of the notes are not accurate. That's maybe because I'm maybe going too fast perhaps, so they're not quite fully getting everything down. So I wanna make sure I pump the brakes, that I can go fast. I apologize if I do. So let me know if I'm going too fast. But hopefully that makes sense that all things at 180, we know this, right? In the triangle, we did that little like scissor cutting thing, we put them together, we discovered, yeah, they're all up to 180, right? So, because they all fall in a straight angle, we might cut and, mark the angles and put them all together. So if you have an equilateral triangle, you have to split it equally among three. So if you split 180 equally, 180 divided by 3, 60, 60, 60, 60, you get out 180. If you have one angle, it's 90, so it's an isosceles right triangle, meaning you have right angle and you have two sides of the same. Because these two angles must also be the same in order for that to work. So you have 180 to share, that's already taken up 90. How much is left between these two? 90. Split that equally, 45, 45, right?
okay. So with that said, you guys should be able to handle part C. Go and try part C. Should be really fast. Tell me what you get for part C. And it's isosceles again. So guess what? These are gonna be x and x, right? Does that equation make sense? And if you work it out, you should get 146. And of course, you don't have to do the math in your head, but if you want, you can. And we know half of 146 is. So I think good. Yeah, half of 140 70, half of 6 is 3. So you get 73 degrees and 73 degrees. Okay, so hopefully that's fine. No issues there with doing the calculation. Okay. Okay, this will finish up 2 and 4 notes before we move on to 2 and 5. Team reasoning challenge. Okay. Work with your team or table group to find the measures of all the labeled angles in the diagram below. Justify your solutions. Okay. All right. Why don't you guys work in this? And we have parallel lines, by the way. Yep. These are parallel. So remember parallel lines. To help you guys out. Remember, these are the same. And then these are the same. Just keep that in mind. I'm gonna do a tool compare in a moment. Vertical angles. Make sure you respect that. I'll come and help you guys out in a moment once I feel like I've got the answers. One big hint. What do you think Q equals, guys? What's Q going to be? Correct, because corresponding. Good. That's huge. Because then the rest of the dominoes should fall.
You done? Yes. Okay, so yeah, so then, so here's the thing, that's what said, starting, right, and shields.
No.
Are we good here? You good? That's great so far. Okay, so if that's what you said, put it out in July. Or the, use a parallel, alternate your equals. Yeah, yeah. So then you should be able to figure out. Less. We're able to 57 it is. But it's right, this can use passive for I guess, yeah, if that's 81, then what's G gonna be? Right, then you get P and I back again. Good. Good, awesome, good.
Sorry.
Alright. Okay, that's also,
57.
this is good, good. Okay.
Okay, we'll do another like 30 seconds and we'll move on.
Yeah.
Okay, here we go. Oh, let me unfreeze the screen. One sec. One thing I gotta take care of here.
Yeah.
All right, I think everyone's got it now. Here we go. 123, 57, 9981, 4257, all that stuff there. All right. Cool. Let's keep moving. We do need to just summarize what's going on with parallel lines. Everyone should have this sheet. I handed this out just this morning. And all the stuff I just gave you guys should be, the single sheet should be in all the handouts you have. I want to do this first, and then we'll go next part. So remember, corresponding angles, angles in the same corresponding position on their lines. So, for example, 2 and 6 are corresponding. They are congruent. Thanks. Alternate interior angles. So 3 and 6 are examples of alternate interior angles. When parallel, those are also congruent or same thing, right? 4 or 5 would also count as well. But like here, like angle 2 and angle 6 are corresponding. Here, angle 3 and angle 6 are alternate interior. Now, same side interior.
How are they congruent if they're different numbers?
No. Those are the labels.
Oh.
They're not measures. Those are labels. Yeah. No, thank you for clarifying that. That could be confusing. Those are labels. Instead of putting letters, because it gets very convoluted if you put letters, they just use numbers as a label. Now, same side interior, like angle 4 and angle 6 are same side interior. Those are going to be supplementary, meaning to add a 180. So those are the 3 big ones that I really care the most about. Corresponding, alternate interior, same side interior. As long as you know those 3, you should be able to find any angle in any kind of situation like this. But those are the 3 you want to lean on. Oh, alternate interior, same. Oh, corresponding, same. Oh, same side interior, add the 180. Then the other ones are kind of derived from that. There's like 3 other ones here. I mean, vertical angles are pretty obvious. These are always congruent. Like, for example, angle 2 and angle 3 are vertical angles. Oh, that's the third one. I put supplementary. Same side interior. Here, I'll write up here. That was supplementary. Supplementary.
You don't like that?
I just haven't. I do. I just want to do this. I don't know. I was just well, no. I have to transfer the files over. I haven't had time to do that, so that's the reason why. So, yeah, I will get back to the iPad. We'll go back and forth. Alternate exterior angles. I'm just faster this way. Alternate exterior angles like 2 and 7. Those are also congruent. So the alternate are outside. And think of it this way, it's kind of like a sandwich, right? Like you have like, the top bun, the bottom bun, but it's outside. 2 and 7 are outside, not inside the sandwich. So it's outside. So that's why it's exterior. Same side exterior would be like 2 and 8. Those are going to add up to 180, just like same side interior. We don't really look at that too much, but just good to recognize.
The 1 and 7 also.
Correct. Those would also be same side exterior. Going back to alternate exterior, 2, 7 alternate exterior, so are 1 and 8. Remember complementary, add to 90. Supplementary, add to 180. Adjacent angles have a common vertex and side, and don't overlap. So, for example, say you have A, B, C, and D. So angles ABC and angle CBD or DBC, however you want to call it. Those are adjacent angles. They're adjacent because one doesn't overlap the other. They share vertex, and of course, they share sides. I didn't have to have app to 180. I could have bent that a little bit. I could have done this if I wanted to. That could have been fine. But those are adjacent angles, just so you know. So terminology, make sure we're clear on that. Adjacent angles, supplementary add 180, complementary add 90. Of course, all these terms here. So this is your reference sheet. We're going to continue coming back to this over and over again to make sure that you guys have this down cold. Okay, good. Not for parallel lines, that won't work. It's like the test that we had where the angles add up to 90. That would have been complementary. Like, for example, if I gave you a situation like this here. That's a right angle, and I do something like this. And say this is A, B, C, D. And say that's like 2x, and say that's like y. What do 2x and y add up to? So those are complementary. Yeah, you wouldn't necessarily, that doesn't have a really a place with parallel lines unless you deliberately draw a right angle somewhere. Sure, yeah, of course, yeah. Yeah. All right, so yeah. Okay, so I want to make sure we're good on that. Okay, now let's move on to 2 and 5. Okay. And again, I'll try to do a problem or two and have you guys try some. Just for my own sanity, I want to make sure we get to this because I'm gonna get a little worried if we don't. All right. So use your knowledge of angle relations to answer the questions below. Getting at parallel lines and diagram on the right. What is the sum of angles x and y? So these are same side interior angles. And you have parallel lines. So if you have parallel lines and the same side interior angles, what do we say about x and y? Are they the same or they add to 180? Add to 180. How do you know? That's because you have parallel lines. That's how you know. But then let's look at this one here. Part B, the person says, well, yeah, if you have same side interior, it's always true. So she's wrong. Because line AB is not parallel to line CD. Remember that little symbol? That means parallel, the two vertical lines that are drawn like that. So you can't say that, oh yeah, that's 100 and that's 80. You can't say that. That's because they're not parallel. I mean, it's pretty obvious they're going to touch. Even though these are even though angle CAB and angle ACD are same side interior angles. Even though. Like these are same side interior angles as well, X and Y for part A, but these are obviously parallel. So they're gonna have 180. These are not parallel. I mean, I don't know. Like maybe that's like 1/3. I don't know what's going on. I can't really, but you can't say that. That doesn't make sense. That wouldn't make any sense at all. All right. So, questions? Okay. Before I move the screen, because I know some people are still kind of writing stuff down, take a look at 248. And go ahead and answer that with your table group. And we'll check in after a minute. I'll freeze the screen because people are still jotting stuff down. And once you're done jotting stuff down, go and try 248 and 249.
Those are actually the same side interior. They're supplementary.
And try to write a theorem or a statement. Good. Okay, am I cool with clearing the screen here? Okay. So here's the next part.
So yes, these are parallel, because the same side triangles adds one to them. Yes, that's good. So you're doing the opposite now. Before I told you, so here's the thing, it's kind of like a proof. If I tell you the lines are parallel, then you know the same side triangle without them. But what if I don't tell you they're parallel? What if I just give you a diagram? I don't label it. And I just do the angles. Angle, right? And you look at it, oh, well, let's have to 180. So what can I conclude about those two lines? The conclude, so you're doing the opposite now of what we said before. Before, if I gave you two parallel lines, you conclude that the same side triangles have 180. Now we're doing the opposite. Oh, what if I tell you, it's called the converse. Okay, what if I tell you that these add to 180? Okay, then the lines have to parallel. So that's the way you would want to write it. Is that if the same side triangles of two lines add to 180 or supplementary, either way I don't care. Whether they say add 180 or supplementary, then those two lines must be parallel. So that's the theorem. And we could prove it, with all the stuff we did in the past, like, oh, you had corresponding angles, you had this and that and whatever. But that's a theorem that we just wrote. Yeah, okay. So now, after we get that down, go and try 249 as well as 253. 249 is asking it to explain why the lines are parallel. And then 253 is asking to solve for X, Y, and Z, I think. Let me freeze that. Yeah, and then we'll do a quick summary at the bottom of the last page. So does that make sense how I answer 48? We're cool with that. Yeah, so we're gonna try 49 53 in table groups. I'll come around to make sure you guys are understanding what to write. And then I'll show you that in a moment. And then we're gonna do another set of notes, but we won't do too much of it, just a little bit.
Do we do the summary? Of paragraph one?
Let's show the answers now. Okay, so let's move on. Okay, for 49. If these are the same,
It's still frozen.
oh, oops, I thought I froze it. There we go. All right. If those are the same, explain why they're parallel. That's because corresponding angles are congruent. Here, those are the same because alternate interior angles are congruent. So just like how we saw same side interior at the 180, you got parallel lines. Same thing here. So that's why those are parallel. So then we can conclude that that is the same as, sorry, those are parallel and those are parallel. So looking back, if corresponding angles are congruent, lines are parallel. If alternate angles are congruent, lines are parallel. So, okay. Then X, Y, and Z. Have you guys solved for X, Y, and Z yet? You did? Ollie, what do you got? Four. I know it's frozen. Yeah, totally agree. Because you could say this is X. So X plus 28 has to add to 180. So 2X equals 156. Split it, X equals 72. My apologies. Sorry, 152. So that's 76. And then you got parallel lines. Y and X are corresponding angles. Careful there. Okay. And then of course, X and Z form a linear pair. Meaning they have to add the 180. So the summary of parallel line theorems, corresponding angles congruent. Alternate interior angles congruent. Those are the three I really care the most about. Same side interior angles. Add to 180. The rest you can derive pretty easily. Those are the three big ones. Okay, we're coming along. Well, sure. I did erase it, but I meant to say lines are parallel. Lines are parallel for both. Yeah, lines are parallel. Yeah. So again, it's pretty straightforward. Alternate interior angles. Yeah, so alt, yeah, MSS, ALT, INT angles. Okay, so everyone's clear on how parallel lines work. So we'll do it in practice, obviously, throughout the week and next week. Our next test is not until the end of the month, so about another, I don't know the exact date. I have to figure that out. I think it's 2 weeks from today. I think. 4, I think. Yeah, it's go to the major category, the major, right. But the next test has more weight, so it'll have more impact. It's at least 17 more points than what we had before. So actually, hold on a sec. Now I'm kind of curious. When do we plan? We also have a project coming up too. The quilt project. We were supposed to start last week, but that never happened. It's like those designs you see on the wall. Yeah. So you guys got to do that. Um,
Yeah.
it goes in the major category. Yeah, I believe so. If I'm not mistaken, I think. But hold on a sec. You guys got the next set of notes because we got to hit that up. Yeah. Next test, I think. Yeah, it's gonna be 2 weeks from today. So that's the plan. All right. So let me close.
I know.
Okay, clear. All right. So next set of notes, you guys should have this 2.2.1. There's 7 pages. We're not gonna do all 7 pages in the next 13 minutes, but I want to do pages 1 and 3, and I think that will make me feel better about where we are. So I'll give my voice a little bit of break here. Lucas, can you read the top of 2.2.1, please? So it says the dimensions.
Oh, wait, me?
Yeah.
The dimensions of a figure are measurements of length. For example, the measurements of a figure below describe the relative size of each top.
Yeah. So like, for example, here you have a block. It's 3-dimensional. It's like 2 by 10 by 8. Here you have a triangle, height is 7, right? So length, I mean, it's pretty obvious. That's just a measure in linear units. Sometimes we use like inches, centimeters, meters, feet, whatever. And it's only raised to the first power, so we don't put an exponent next to it. But area has square units. So we raise it to the second power. Example could be like square feet. So for example, if you look up your house or wherever you live on Zillow, and they told you the square footage, that's basically the area of your house, right? So they'll also do the same thing for the lot, like the front yard, backyard, whatever. And how do they do that? Well, they look at each room in your house and they say, okay, let's measure the size of the room. So like for this room, right, I'd have to get like a measuring tape. Okay, that's like, I'm guessing maybe 20 feet and 30 feet. So that'd be 600 square feet. But you have to use square units because you're multiplying 2 dimensions. Length this way, length that way, or length and width, whatever you want to call it. So area is always in square units. But we don't do volume for a house. That's kind of weird because I'm not going to hang out in the ceiling or float in the middle of the air. So, so it's all about, but for volume, that's going to be cubic units. That's raised to the third power. So for example, your water bottle, right? Like, how much water you can put in there. We use volume to measure that. So that could be in cubic feet. You could use like, you could use like centimeters, inches, whatever, it doesn't really matter. But you have to cube your dimensions. So for example, if I had a box, I want to measure the volume it could take up, I'd have to measure length, width, and height. For the water bottles, that's more of a cylinder. That's a different formula. You have a circle times the height. That's something we'll talk about later in the year. So 264, Reagan, can you read 264, please?
1,680 inches next period. How are you supposed to say reach? Or can your 0.0003097 miles on your birth? Do you have any idea of how long that is?
Yeah, so those are weird, right? So what we want to do, those are very, very strange. Like, for example, a car, right? Like, okay, I mean, obviously we talked about my car getting damaged, but what if I actually got into a car accident, which is not good? If I was running like, say, 100 miles per hour in El Camino, that's kind of crazy, right? That's really, really fast. Like, what's the speed of El Camino? Does anyone know? 35. But if you go past 35, sometimes you can get a ticket. But if I said, oh, well, the speed limit on El Camino is like 70 feet per second, like that's kind of weird. Like, I don't know, is that fast? Is that slow? Like, that's kind of weird, right? Or if you know the country, they do kilometers. Like, we're special here. We don't want to use kilometers. We do our own thing. But, it's weird, right? So we want to be able to convert. So a big part of this is that we need to understand conversions. Like, I'd want to convert those inches to probably miles, maybe, right? Or I want to convert the miles for the length to probably inches. So we would have to use the appropriate unit of measure, or otherwise we have to convert. So, for example, the distance traveled from home to get to school, what do you think would be a proper unit to use for that? Miles, yeah. Now, if you live, say, in like some of you guys might be studying abroad, or not studying abroad, you guys are not college students, sorry, on exchange. Let's say like some go to Spain, some go to France. What did they do in those countries? They do kilometers, yes. Again, we're special here. The surface of a soccer field, okay, or Gator Nation field, right? If you want the surface, I'd probably do like yes, but if I'm looking at the surface, I want area, so I do square yards, or maybe I do like square meters. So a football field, for example. You can, but that's gonna be a little tricky because, like, let's look at a football field, right? How long is a football field? 100 yards, and then you have the end zones, which I should know this. I think 10 yards each. Now, how wide is a football field? About 20. Yeah, I think it's about 20. So, but see, if I did that in feet, that'd be 60 feet wide and 360 feet long. That's gonna be too large. So I'd probably avoid doing that. That might be a little too complicated. The width of a strand of hair. Millimeter, yeah, ooh, good. Yeah. Yeah, it's very thin. The length of your nose, probably inches. Centimeters could work, yeah. The amount of room, that's volume, by the way. Now your locker is kind of like a box, right? There's like, length, width, and height. Probably might be good to measure each of those in, yeah, like maybe it's a foot long, a foot, like 2 feet tall, a foot deep. Yeah, I'd probably do cubic feet, that.
Why'd you write volume?
Because of space. Space.
Space. Because you try to jam all this stuff in your locker. Well, some of you guys don't use your lockers on here. I think did somebody get in trouble for not using our lockers? School. Yeah, exactly. They did a backpack sweep. So if you don't lock up your backpacks, the seniors get lazy, don't do it. So yeah. Actually, during the pandemic, we used the lockers to store papers, and kids would come and pick up handouts and then go back home. So we were used for that reason. Just a few more things before we wrap up. What's this all about? Yeah, we'll come back to this because I'm not sure what's going on at this page. Let's look at page 3 really quickly. Let's talk about area, and then we'll wrap up for today. Okay, area. If you are not sure, the area of a triangle is 1/2 base times height. Okay, you're not sure. Area of a triangle is 1/2 times base times height. So your base is 14. Your height is 5. If you think about it, isn't that triangle half the rectangle?
Yes.
Right? So this triangle is half of the rectangle. And the area of a rectangle is base times height. So naturally, their triangle should be 1/2 times base times height. So in this case, I know that's just gonna be 5 times 14, but times 1/2. Half of 5 times 14. We realize 35 square yards. Because it's square units, because you're multiplying yards and yards. So like, for example, you multiply x and x, like x must get x squared, or 2 and 2, 2 squared is 4. So we're gonna do something similar for f. And then I'm also gonna have you actually we'll just do f and we'll stop there because I don't want to rush 72. I think we'll say it for next time. So lastly for this one here, this will be a nice little way to end for today. If you think about how long is this base?
14.
And the height's what?
5.
So half. It's the same thing actually, yep. And by the way, the double markings is inches. So you say square inches. So 35 square inches. Okay, we'll go and stop there. Homework, you actually have it. I printed for you guys. Homework's right there. I'll need to update Schoology so it's clear what you have to work on. But yeah, that's all. Yep. I crossed out one of the problems. And I put a reference sheet for shapes. You guys should already have it, but I just put it there anyway. Yep. That's your homework. All right, good. We got a lot done today. Good. Stop.